All right, welcome to the 2.5 examples video. Jumping right in, we're on, I don't know, one of the earlier slides. Find a polynomial that has a 0 of 3i. So looking at this, because I have a 0 of 3i, we know that x is equal to 3i. However, this is an imaginary number, which means that it has to have come in a pair. So it has to also come with its conjugate. Our conjugate then would be x is equal to negative 3i. And again, that's because it was an imaginary number and those have to come in pairs. So we want to write a polynomial that has this 0, but also this one. When we're writing polynomials, we say f of x is equal to, and it's always x minus each of the zeros. So x minus 3i times x plus 3i. And then I'm going to multiply this out. If I multiply this out, I get x squared minus 3xi plus 3xi minus 9i squared. So we can see right away the negative 3xi, positive 3xi cancels. My I squared, remember that in section 2.4, we said that I squared was really negative 1. So this just becomes a plus 9. We still have our x squared. So we get f of x is equal to x squared plus 9. There we've written a polynomial. It has two zeros, 3i and negative 3i. All right, moving along, find all zeros of f given that 3i is one of the zeros. So knowing that 3i is one of the zeros, I have x equals 3i. And just like that previous problem, we can also say x equals negative 3i. And if we wanted, what we know then is two of the factors are x minus 3i, x plus 3i, which is the same as x squared plus 9. We did that right here. So two of the factors of this entire polynomial are x squared plus 9. That's two of my linear factors. They've just been multiplied. So what I can do is long divide x cubed plus x squared plus 9x plus 9 by x squared plus 9. Because I know that this is one of the factors, so I know it's going to divide out nicely. Again, this division process, x times x squared plus 9 was going to give me x cubed plus 9x. I do the sign change, so minus, minus, this cancels, this cancels. Bring things down, x squared plus 9. 1 times x squared gives me x squared plus 9. Sign change, those cancel, I get no remainder. So here I can see that my other factor is going to be x plus 1, which means my other 0 would be negative 1. Now, you may not like that. So what we can also do and should always do is look to see, is this factorable in the first place? If I was looking to see if this is factorable, I would see that I can factor by grouping. So on the left, I can take out x squared. On the right, I can take out 9. As long as these match, I bring that down. If they don't match, I can't factor by grouping. And the other two, I just write side by side, x squared plus 9. So now I've factored this. If I were solving these, I set them equal to 0. So I get x equals negative 1, x squared plus 9 equals 0. So x squared equals negative 9, and x equals plus or minus 3i. The question only asked for all of the zeros. What I did here in pink, what that is sort of ignoring the fact that it gave us one of them. It's saying, hey, cool, I'm so glad you gave me 3i as one of the things, but I can do this without knowing that. And that's fine. In blue, what we've done is used what they gave as a solution, used the conjugate of that, and then guided that as the process. Either one of them is fine, and I personally think that if you can do what we did here in pink, we always sort of should. It's usually quicker and easier. All right, moving along, find all zeros and write the complete linear factorization of x cubed plus 4x plus 14x plus 20. So first, if you tried to factor by grouping here, you would not get these matching binomials, which means we cannot factor by grouping. And then we look at it and we're like, okay, I can't do a trinomial because it's not a trinomial. I can't do dots. I can't complete the square because this is cubed. So what we have to do is the possible rational zeros test, where we're going to say we have plus or minus all the factors of 20. So 1, 2, 4, 5, 10, and 20 over all the factors of the lead term, which is just 1. So here I have 1, 2, 3, 4, 5, 6, and the positive and negative. So there are 12 different things to guess synthetic division by. Let's say, for instance, though, that this is a calculator question. What I would do is list these in pink. It's part of my required work. Then I would go to my calculator. I would graph this. And graphically, what I would see is an x-intercept at 2. So that would tell me divide by -2. So I saw that x-intercept at -2. That tells me I'm going to synthetically divide by -2. It's giving me which one of these things to actually try, instead of doing all that random guessing. Then I'm still going to do this synthetic division to show that it really is a 0. So here I get x equals -2. That's one of my zeros. Because this is to the third degree, there should be 3 of those zeros. So looking at what I have left over, this is x squared plus 2x plus 10, and I'm looking for when is it equal to 0. Now, this does not have, or it's not factorable. So what I'm going to have to do is complete the square. I can now because it's a quadratic. So I'll have x squared plus 2x plus blank plus 10. Half of 2 is 1 squared is 1. So I just threw in a positive 1. I balanced that by subtracting 1. I get x plus 1 squared equals 9. Sorry, plus 9 equals 0. So x plus 1 squared equals -9. Just going to continue this solving over here. That gives me x plus 1, well, just x plus 1, is equal to plus or minus 3i. So what I did at this point is square rooted both. That gives me the plus and minus. The square root of a negative is I. The square root of 9 is 3. Then I just subtract my 1. And the way this is written is -1 plus or minus 3i. So what we did there is we synthetically divided. We used our calculator to sort of guide that. Then we completed the square, solved so that we can get the other zeros. So I have x equals -1 plus 3i and x equals -1 minus 3i. These are my zeros. My linear factorization is when I say f of x is equal to, and it's x minus each of these zeros. So I'm going to have x minus -2 becomes plus 2, x minus 1 becomes plus 1, minus 3i, x minus -1 becomes plus 1, minus -3i becomes plus 3i. So that is my linear factorization. It's factored, but it's also factored in a way where everything is a linear equation. All right, we're just going to do another one of those examples. So find all zeros, and again, write the complete linear factorization. Let's switch to blue. If I'm looking at this, I have x cubed plus 11x squared plus 39x plus 29. I recognize personally right away that this is not going to be factorable. So I go to the rational zeros, which would be plus or minus 29 and 1. Again, I go to my calculator and I'm like, I don't really even want to do these 4 synthetic divisions. Plus, if I picked 29, that's a pretty big number to be multiplying by. So I'm just going to go to my graphing calculator. I'm going to see where that x-intercept is. I see that the x-intercept is at -1. So I'm going to show now that really is one of the zeros, and that's something I expect that you do as well. Negative 1 times 1 is negative 1, that gives me 10. Negative 1 times 10 is negative 10, that gives me 29. Negative 1 times 29 is negative 29, I get 0. This 0 tells me x equals negative 1 is one of the zeros. There should be 3. Now I've got x squared plus 10x plus 29 equals 0. This is also not factorable. So I'll have x squared plus 10x plus 25, just completing the square now, minus 25 equals 0. So x plus 5 squared plus 4 equals 0. Solving this, I get x plus 5 squared equals negative 4. Continuing over here, x plus 5 equals plus or minus 2i. I just square rooted both sides. So x equals negative 5 plus or minus 2i. So my zeros, negative 1, negative 5 plus 2i, negative 5 minus 2i. My linear factorization means f of x equals x minus each one of these. So x plus 1, x plus 5 minus 2i, x plus 5 plus 2i. When you are doing these questions in the homework or on the not on the notes, that's what we just did, or in a quiz or on a test, a question like this where you're using your calculator to get the rational zeros, you need to give me this P's and Q's test. You need to tell me essentially that you're doing the rational zeros. You need to do the synthetic division. The synthetic division is what's telling me that that really is a 0. We needed to complete the square here because we were getting something in the complex number system, so we need to know how to complete the square. And then make sure we're answering all parts. It asks for zeros and linear factorization. So writing out the zeros, writing out the linear factorization, and notice I sort of made them easy to find. As you're going through that homework, again, keep in mind there is a lot of work that goes into these, but it's not usually very difficult work. It's just sort of tedious stuff, which isn't that bad. All right, get started and see if you have any questions that can be answered as soon as we come in tomorrow.